Our next speaker is Sean Elliott. Sean M Elliott is a writer and presenter who has worked for over a decade in science communication. He's been working with groups such as CSIRO, Museum Victoria and the University of Melbourne. With his business, Rough Science, Sean presents science programs to school students, including holiday programs where he teaches kids how to make computer games. So please make him very welcome.
I'd like everyone here just to do something for me. Right now, just picture space. Just put a picture in it in your head. What do you see there? Is there like a planet, planets, maybe stars, nebula, galaxies? Whatever's there, it doesn't matter. There is no right answer here. Now, take a moment, just stop looking at it and listen to it. Listen. If you want, close your eyes. Don't you hate it when people do that? Listen to it. What do you hear? Da, 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 dun, da, bum, 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 bum. No, not for you? Okay, so maybe for you it might be more... No. And feel free, if you'd like to, sing along when you get this one. Da 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 dun da 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 dun da 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 dun da dun da 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 da. Well, no, none of these. Well, in actual fact, we're not listening to space here because really, in space, no one can hear you sing the Doctor Who theme really badly. Just take that picture of space for a moment, and I want you to do a few things with it. First of all, I want you to think of that picture in space, but change the time. It is now 1967. And now I want you to shift through space to our solar system. Our sun's in the middle. You can see all the 8 planets right out to Pluto, which at this time is still a planet. It's the 9th planet. Shh, don't tell it what's going to happen. Now we're going to focus on one of these planets. We're going to focus on Earth, and then we're going to focus on England, and then we're going to focus on Cambridge, and we're going to focus on a field in Cambridge. Because in this field in 1967, there is something that looks like a whole bunch of fences, really weird, big fences, or maybe clothesline for, really small giants. Any English teachers out there? Now, in amongst this grid of wire, this great big rectangular grid of wire, is a young scientist. And her name is Susan Jocelyn Bell, later to be known as Jocelyn Bell Burnell. Now, she is tending to this grid of wires. Now, this grid of wires is very hard to move around in this place. To keep the grass down, they have to let the sheep in. And Susan has been working on this for quite some time. She's helped design these wires. She's helped to build this thing, and she's currently tending to it. In fact, right now, she has a PhD. She's finished her PhD in physics. In fact, her road to science has been not exactly a straight course. Back when she was still in college in Northern Ireland, the college that she was at didn't allow the girls in the college to study science as one of their things later on in college. They were encouraged to do instead cooking and cross-stitch. But her parents, along with a whole bunch of other parents, kicked up a stink about this, and she was allowed to study science. But then they did the version of HSC, VCE at that time, and she failed at that. This was a system called 11 Plus, and it was quite controversial at the time. It eventually got thrown for another education system. But because she failed there, she then ended up going to a boarding school in York, a Quaker school. And it was there that she met her physics teacher, who just inspired her in a way that she had never been inspired before. And for her, she said later that to learn physics from him, he just showed how from very simple concepts, great, magnificent things come out of that. And she just embraced physics. And later, eventually went to Cambridge and got a PhD in physics, and now is in this field tending to these wires. All of these wires are part of something which is called a radio telescope. Now, I have to admit, when I say the word radio telescope, the thing that pops into my head is, is a giant dish, like in that movie, The Dish. So by this stage, radio astronomy is still a fairly new endeavour. It was kind of discovered by accident about 30 years beforehand in the 1930s, about 1932 or so. A technician who was there trying to figure out interference for radio telephone systems built this giant movable antenna, and during this time he figured out there were three main sources of interference for this particular radio telephone system, which was basically thunderstorms that were really close up, thunderstorms that were really far away, and something else. And that something else, it was a bit hard to figure out where it was coming from. And after a little bit of moving around, he figured out it was coming from up there, up in space. There were signals coming down from space. And so from here, people started searching the sky for all of these new signals, these new exotic bodies that were out there. And because by this stage, astronomy was all about the visual. You go and you look. You get telescopes that collect lots of light, and you look, and you take photos, and you look. But suddenly with radio astronomy, we could start to, look at other parts of the electromagnetic spectrum. So vision involves the visible light, which is just a small fraction of it. We've got all of these other wavelengths that we can explore. And so in this field in Cambridge, this is exactly what Jocelyn Bell is doing. So essentially, her task was to go through kilometers, and they were actual literal kilometers of paper that had little markings on it, which told the listener essentially what was coming down from the sky. And so she would go through the signals, which was marked with this wiggly line, and she'll be sifting through for interesting things and trying to sift it out from all the other things which were, this was 1967. There were lots of things making radio signals by this stage. Like, for instance, local radio stations and electric motors. And this is still a problem we're discovering today. Like, for instance, microwave ovens. Okay, the astronomers seem to be mainly in that area. Google it later. Recent news. Anyway, she had to go through these lengths of paper and try and sift out the signal from the noise. But really, at the end of the day, it's just noise and noise. And trying to figure out what is the stuff that they're interested in is difficult. One of the things that... one of the ways to see what was the interesting stuff is to look for things that would follow sidereal time. So essentially, if we imagine we're standing here on the Earth is rotating in space, and we look up at the stars have a particular pathway across the sky. And if things are far enough away, they're all going to move in the same way that stars do. When they're closer to us, things like the sun and the moon and the planets, they're all going to have their own movement against this background. So if this signal has a sidereal time and we can locate it in a particular part of the sky and it's always there, then its chances are it's going to be really, really far away from the Earth and something interesting to look at. Now, so she was going through looking for these sort of objects. Now, one day, she's going through one of these kilometers of paper and she comes across a scruffy part. They're her words. She said, I found this scruffy part. And so she got this part and she enhanced it, which was to look closely at it with a magnifying glass. And basically she saw a series of peaks. And the interesting thing about these series of peaks was that they were very, very regular. So if we took these peaks and we turned it into sound, it was da, 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 da. so on and so forth, like this. And on top of that, it had a sidereal time. We could locate it in a particular part of the sky. So she discussed this with her supervisor, a scientist named Anthony Hewish. And they wondered about what is it that could be making this signal? Now, look, the tempting thought did come to them. What if? It's a regular signal like this. What if it's an alien civilization somewhere out there on some planet going around its own sun? Maybe something like that. They entertained the thought, but really at the end of the day, they weren't that serious about it. But still, tongue-in-cheek, they still called this signal LGM1, Little Green Men 1. Well, this was 1967. That was the cliche, science fiction cliche at the time. If this was the 1980s, I suppose they'd probably call it armor-plated killing machine that lays eggs down your throat and bursts out your chest. 1. So they had essentially discovered, just to cut a long story short here, they had discovered a pulsar. And a pulsar is essentially remains, one of the many sort of exotic remains of a dead star. So essentially the way to think about this is stars of a particular size. And in this case, we're looking at stars that are probably quite massive compared to our own sun, say 10 times the mass of our own sun. Through their life, they are converting hydrogen into helium in a process of nuclear fusion, which is giving it the energy that's coming off them, their light, the heat. But inside these massive stars, they also start converting helium into other heavier elements, so things like carbon and iron. Now, at some point, these massive stars are going to run out of stuff to convert. And at that point, they explode. Now, look, we could go through the physics of all this, but just basically, supernova, we've got stuff flying off in all directions. But the stuff that remains, about 10% of the mass goes 90% of the mass goes flying off in all directions as these atoms flying off into the universe. The rest of it collapses down into itself. And the energy of this collapsing means that the stuff that is making up the remainder of what's there, so all of the atoms, so if you go back to chemistry and think about what's in an atom, we've got neutrons, we've got protons, we've got electrons. The electrons and the protons, they combine together and form neutrons as well. In fact, basically you end up with nothing but neutrons inside this thing, a neutron star. And it's very small. Could be about 12 kilometers across. But they are incredibly dense. In fact, they're so dense that if you were flying around in universe and you came across a neutron star and you'd look at it, you'd see one half of it looking at you. But, looking at you. Spooky. Okay. You've got one half of it, you'd look at it, you'd see one half of it, you'd also see a little bit of its back half, because light bends in a relativistic way around this dense object. To be honest, though, if you're that close to it, you're probably not too worried about how much of it you can actually see, because you're caught in its gravitational field and currently being pulled down to the surface of it at a force that's going to basically smash you into neutrons as well. These things are sucking matter in and just forming more neutron star. So they're huge. They're very, very dense, quite small. But on top of that, they're spewing out electromagnetic waves out the ends. And this is one of those moments in science where a lot of this theory came up a long time before the observation. So the thought about these objects being out there had been proposed. And so the idea was, we've got one of these neutron stars, it's got electromagnetic waves coming out, and it's spinning as well. And what we're observing on Earth is like a lighthouse. Every now and then we get a flash of this stuff as it passes over us. And it's spinning incredibly fast. As we said, Jocelyn Bell's observations, it was about one pulse every second and a quarter. We've now found pulsars that are actually spinning many times faster than that, maybe even thousands of times a second. So This was an amazing discovery because she had just seen something that had been never, ever seen before. Well, not seen, detected using the radio telescope. And it was a discovery that won the Nobel Prize. It was fantastic, a marvelous achievement. In 1974, the Nobel Prize went to Anthony Hewish, her supervisor. She was not mentioned at all through the entire ceremony and presentation. Now, that said, if you were to go and look up pulsars now, her name are all over them. The outrage at the time about the fact that she had missed out on this discovery, and yet she was so key in actually making the discovery, was so large. One of the astronomers at the time, Fred Hoyle, he was so angry about this that he accused Hewish of stealing data, and he threw accusations at the Nobel Prize Committee to the extent that the Nobel Prize was possibly going to be awarded to him in about 1983, but he was then kind of quietly pushed to one side. Anyway, I want to end this just thinking about hero status, because we've been talking about heroes tonight. Mark mentioned before about unsung heroes, and Jocelyn Bell Burnell could almost have very been one of those unsung heroes, but she certainly isn't now. She has got many awards to her name, she's got many doctorates, and she still works in astronomy today. But this idea of heroes, but in particular why she's my hero, which is, well, look, Richard Dawkins, he has this thing that he says, where he says that there are two types of science. For me personally, I like to take that and just push a little bit further and say there are two types of science communication. In that, he said, there is non-stick frying pan science and there is supernova science. Now, non-stick frying pan science, that's basically you go and look for a reason for scientific research. Why did we have the space program? Well, we got non-stick frying pans out of it. Yay! On the other hand, let's forget about the actual physical material thing that we get out of something and think instead about that other kind of science communication, supernova science. Because if you think about what Jocelyn Bell did, she discovered something and it added to this story that we have about the universe, which is stars. And stars have this life cycle, and they, in their life, make heavier and heavier elements. But in their death, we now spawn this kind of new chance for new life out there of new stars forming. This cloud of gas, this 90% of gas flying through the universe, hits other stuff, and we get more stars forming. And then from their deaths, we get more stars forming, and maybe we get planets, and maybe we get different kind of life, the sort of life that we all know about. And ultimately, this is a creation story that I can get behind. So for Dame Jocelyn Bell Burnell, discovering a piece of this picture, the little piece of this soundscape, and a little part of the story of the universe, this is the reason why she's one of my heroes. Good night.